On behalf of BBW, I would like to welcome you to the maintenance training for non-invasive ventilators for service technicians in public hospitals. The CPAP or CPAP 100 ventilator was developed by the South African Emergency Ventilator Project SAVE-P. My name is Thorsten Löffler and I work as a project manager for BBW. BBW is a German education institution with a strong linkage to the industry. BBW operates in Germany but also internationally. This maintenance training in different hospitals in South Africa is offered in cooperation with SAVE-P. It marks the first phase of a short-term project which runs from December 2020 until April 2022. The short-term project is a joint program between BBW and Tshwane University of Technology in Pretoria. After the first phase, there will be a second project phase. The aim is to develop a curriculum and training material for a course with the topic Maintenance of Medical Devices, which will be offered by Tshwane University of Technology. Participants for the curriculum development are service technicians from public hospitals and lecturers from Tshwane University of Technology, as well as other stakeholders. Now it's time to get started. Enjoy the training with Robin from SAVE-P.
Morning, ladies and gentlemen. Thanks for attending. This is a level 1 training on the CPAP. It's a test procedure that has to go through every 3 months. It's also got to be registered on the SAVE-P website. So once the tests and that are done, it has to be registered. There is a link that you will follow, and all your test results and that have to be registered. Otherwise, the guarantee will be forfeited. It's a very simple thing. I know you guys are highly qualified as clinical engineers, but it's a simple test that has to be done. What you do need is you need a fluke analyzer or a ventilator analyzer that can do flow and percentage. Don't worry about the volume of flow. All you want is the flow rate and a percentage that you can read, and a pressure. With the test thing, you have a valve, CPAP valve here, okay? A pressure valve that you can control from 20 to 60 centimeters of water. Your tests involve 10 centimeters of water and 20 centimeters of water. Those are the two markings where your tests have to be carried out at. When we use it, we like to have a filter on the end to stop any dirt coming in. You know how sensitive these units are. If you get dirt or anything filtering in, you will have problems with your readings. Okay, I'm not going to go too much into that because you guys know who to contact for analyzers should you need. With the unit, when you get it, all right, it will come in a complete box. It should have an instruction manual in it. It should have a service manual in it. It will have your circuits. They have added a humidifier, okay, as a last resort. They put it in because this humidifier, CSIR, it works with our unit. So it's been included. You will have patient circuits, masks as a complete unit to be set up, all right. Okay, for the 3-month test, all right, it's purely calibration. If your unit's been working, even if it hasn't been working, a unit that doesn't work is not necessarily a good unit. It's like a car, like anything. The more you use it, the better it is, okay? So it is required to have that test. Do a physical visual test on the unit. Check the hoses, check your Haya probes, check the high pressure hoses, check your fittings, just check the general look of the unit. If this unit does fall, that is your control, your oxygen percentage control, that will get damaged. It'll bend the spindle, okay? You'll see it because when you turn the spindle, obviously you're going to get a problem with it. Check your on-off switch, just in general check everything, because you'll see if it's had a fall. you're bound to see some damage on the unit. Okay. Once you've checked the unit, also underneath here is a tamper seal. Just check that that hasn't been tampered with. And I mean, if someone gets a blade, you can slice it, and believe me, you might not see that it's been tampered with. But if you have a good look at it, it's noticeable. With the unit, plug it in, check your wall pressures. Check that you have got sufficient wall pressure, which is normally in the region of 420 to 450 kPAs. Okay? If you've got a big variance in your wall pressure, because this unit has got an oxygen blender in it, they have the differential of pressures, you'll get an alarm, a whistle. So check your wall pressures before you start here and saying, oh, there's a problem here. Firstly, you want to check those audible whistles. Okay, that means, you know what this means. Either only one gas is connected. Okay? So you want to check now that it rectifies itself. Do the other gas, oxygen, pull it out. You must get alarm as well. So we've checked the air, we've checked the oxygen. Okay? And it's as simple. You have, that is your recording list, all right? It's got there the alarm test. Okay, so now you've checked the alarms. The alarms are working. So if you plug in both of them and you still get an alarm, there could be a problem in your pressure on the walls. When it's connected like this, what you want to do is, like we've done, switch on, switch off, just to get a flow. Don't worry about where your flow is set. You just want the unit to hear it working. What you will be doing when you switch it off now, you'll be checking the on-off switch, that it is working correctly, that there's no leak. So now when it's off, obviously you should have no flow. You are allowed a certain leak past that, very, very slight. It should be off. When it's off, it's off. Sometimes you get a slight seepage through. These things are very, very sensitive, and it'll pick it up that there's a slight flow. You know, if you've got, when you switch it off and it carries on flowing at 4, 5, 6 liters a minute, you've got a problem. Okay. Don't try and fix it. A unit like that has to be labeled, sent through. There's a problem with that unit, and then it will be returned to us so that we can actually strip it down and have a look at it. Okay. So level 1, no tools allowed, no tools you need at all. You might need a screwdriver where you can adjust the gauge if the gauge is reading out slightly. You now want to just check the gauge as well, all right? So what you'll do is you'll switch it on. We'll go down to 20 liters a minute. Use this valve here to adjust up to 10 centimeters of water, roughly 10 centimeter water reading here. Just make sure that your gauge is reading roughly. Remember, gauge is not a precision instrument. It's purely a visual display. Yes, we've got airway pressure. So do that on 10 and then up to 20, round about 20. Make sure your gauge is also reading plus minus in those regions. All your tests will be carried out for your flow rates and your percentages will be at 20 liters a minute and 60 liters a minute. Nothing in between there. Just check it on 20 and check it on 60 to see that your flow rates and your percentage calibrations are within the specs. What I'm going to do is explain. Inside here, you've got your connections at the back, okay? Your oxygen and air, non-interchangeable, all right? That is your whistle. Make sure no one covers that up, because sometimes with alarms and that, everyone likes to silence them. And if they can't silence them, they'll stick something over them, okay? You're going to get plaster and you're going to get gauze, you're going to get everything stuck over there because it's annoying. It's annoying for a reason, okay? In here, your main device inside this unit is a blender, an oxygen air blender. That is your driving factor here, so that You don't have to worry with an entrainment system, a Venturi system, of what percent am I going to get if I do this, or if someone blocks the Venturi, I don't know, or something, dirt gets in the Venturi. What happens? Here, you've got a blender, because if you want 20%, 21%, I get 21%. If I want 100, I get 100. It's just easier for your patient. All right. All that does, it flows down through to the on-off switch. Your on-off switch, as it is, on, off, your flow rate comes through, and you've got a flow calibrated control valve from 20 to 60 liters of water. And a gauge. That's how simple the unit is. It's very, very simple. All pneumatics. We didn't want any electronics or any electrical connections or anything for this unit. It is made to be very, very simple for anyone to use. So if you've got a power failure, we don't have to worry about this because it's purely pneumatic. When we test this unit, there's the 3 monthly test sheets. I'll pass it around, you can have a look at it. It's self-explanatory what you have to do. All right? So initially we will start on 20 liters a minute flow. All right? We will start on 40%. All right? You can check it on 21%. And and you switch it on. Obviously with your unit makes it easier. There's your flow rate, 22 liters. All right? You're allowed, it's up to 25 if I remember correctly. Your acceptable range is 12 to 28 liters. So you've got a big leeway in, we looked at plus minus 15 to 20%. Okay? And you check your percentage, it's at 20.6. So what you do then is you will then fill in here. Or else you can actually take a picture and you can send in pictures if you don't want to send in charts like this where you fill in and sign. You can send in pictures, but then the final signature will be on the bottom here. Okay. So all you do then is you go through. Then the next is to 40 liters a minute. All right? And you do the same checks again. But you go, let's leave it on 20, then we go 40%. And we check our readings again. Then we check on 60%, and we'll check again on 80 and 100%. That we've got our readings for 20 liters. All right? Then we'll go to 40 liters. You can check 21%. I always do. I mean, by rights, there should not be any leakages there. You might have a very, very 23%, 22%. That is still fine. Okay? And then you go through again and you do your percentages, 40, 60, 80, 100 on your flow rate of 40. Then you have a flow rate of 60 and you go exactly the same again. 21, 40, and record all those. And down here it gives you your specs, your flow rates that your tolerance that you should be in. Your tolerances are down the bottom. If it is out of tolerance, don't try and fiddle with it. You've got to get the flow rate and the blender readjusted to bring it back well within the calibration. Because believe me, a slight twist on even on the control knob, if you go, like some people carry on and they really want to force it, you will damage that spindle. It's just a needle valve. That's all it is. A brass needle valve. Okay? That's all it is. So just handle it with care. We've checked the gauge, we've checked the on-off switch, we've now checked all the percentages. Once it's finished and you're happy that everything's silent, that has to be logged onto the SAVE-P website so that this unit is then, yes, it's had a 3 monthly check. Even if it hasn't been used, please just do it. Do those checks that are necessary. All right. That is as simple as it is. That's it. Questions? Yeah, SAFRA, they okayed it as the emergency ventilator project. And yes, there are more procedures we're going through, because we've had a lot of calls that this, not only for COVID, they said there's a lot of other patients clinically that they could use this on for high flow, patients who need high flow. Instead of being intubated and ventilated, they would rather have a patient just on CPAP. This is the simplest CPAP. I think you guys know there are other CPAPs with electronic controls and all sorts of other measurements, all right? This base is basic. And yes, it can be used in many of those other instances. At the moment, it's sort of open to negotiation further, and that's why they are busy taking it further now to get full registration, that it can be used post-COVID. We'd like it. And we've had numerous people saying, please, we would like to use this unit post-COVID. Have you got test analyzers now at the present moment that can just do, for example, flow rates?
I don't know.
Have you got any ventilator test units that will give you a flow, because you need to do a flow rate from 20 liters to 60 liters. So if you've got any analyzer that can do and register that flow rate, and even a handheld oxygen analyzer to test that, 20 liters. Yeah, yeah. No, unfortunately not. No. I mean, it can be readjusted again. It's simple to do, to bring it into line. So if someone is requiring only for peds or something like that, that you want down to sort of 3 liters a minute. But there again, if you're wanting something that low, you're going to use a flow meter blender. You're going to use a flow meter plugged straight into a wall from 0 to 5 liters. And you'll probably have a flow meter connected to a blender anyway. Every single one of these units, probably in the box you'll see my signature, because every single one of those units was tested. 2,000 units was tested by that. But they will have in Roslyn at the factory, and I can find out exactly where it was sent. Or okay, just another thing for you guys to be aware of is it went to the central stores, the HTU unit. I don't know whether I don't know whether you communicate with them. Health technology unit. Everything goes via them, distributed to the hospitals. They get to the hospitals. Now the stores people have opened it up and put it together. I'd prefer a clinical person to put it together. Reason being, he knows there's an instruction manual in there. Yeah. Don't lose it, or don't just, we don't really need that. That's another piece of paper. And to check that, yes, all the circuits are in there. You have got a humidifier. You have got the correct stand for it. And, you know, it's a clinical person that should actually put that together. The only upgrade we did is we actually said we need to be able to adjust those gauges. I mean, to have a simple gauge out by 10 centimeters of water where you can recalibrate it, is just a no-brainer. Sure. You know, that's why I said, all right. And all these gauges were actually sent back to Romberg, and they drilled them for us and sorted them out for us. So that's the only upgrades I can think of. But if this is one of the first ones you got, yeah, this is one of the later ones. Yep. Oh yeah. This is the one near the end of the 1848. So this one will have everything. If you had the test units, they were a different color to this as well. They were a darker metal, gunmetal type of thing. Any other questions, guys? It's well within, your capabilities, let me tell you. I'll chat to them about that so that in case there's a very basic fault with the gauge, you guys can just replace it. But once you've replaced it, you need to have your stickers on underneath, those temper stickers. You know, I don't want to have to run just to replace a gauge. And you don't want 5 units out because the gauges are way out. But if we can protect that with those T-pieces and that's why initially on installation, that's the first thing should go on there and say, please do not remove any of those. Because in the initial design, and it was discussed that your safety features are going to be on your patient circuit, your PEEP valves, everything's going to be on there. So we said, all right, that's fine. Then we won't include it in here. These can be driven off tanks, oxygen tanks with regulators on them, preset. They can be run off that, yes. But it was aimed at, this unit was aimed at, it had the facilities to supply to the very the rural hospitals and that, to supply them an oxygen concentrator bank that can drive 50 psi and an air bank. That was the whole aim. For outlying hospitals, if they take those units and that, it's in the interest to upgrade to a smaller, you know, not the big concentrators and that they've got in containers. Something smaller that can drive up to 50 psi or 420 kPas. But if they've got air, if they've got oxygen, like a lot of wards have got oxygen, but they don't have air. A lot of wards are like that. I mean, you go into a ward, they're not going to have air. Your ICUs, your high cares, your NICUs, they've all got the air. And those are normally always full up anyway. So basically your COVID ward should have air and oxygen. Unless you've got a Venturi system, which then you don't need. So these can be run off cylinders. Oxygen air cylinder. Well, on your oxygen, on your regulator's got more than enough flow rate. Now that is totally settings. 60 liters a minute. You know, a big bottle like this, I promise you, we were testing 100 units a day on those cylinders. And we were changing them once a day on the big cylinders. And that's going through that full test procedure that I was doing and more on high flow rates. Because we wanted to, the aim was to see that we can maintain that high flow rate. So we did other tests, but then the final tests were done. And those bottles lasted. I was pleasantly surprised. But there again, if that was 1 per 1, if you have a bank of those driving 5 of these, that's the other side. Have you got sufficient flow on a bank of 5 cylinders, driving 6 of those? Will there be sufficient flow? If they're all on 60 liters a minute, think of that. You're probably not going to have it, no. No, not through you. It's what, basically quarter, isn't it? Quarter inch, yeah, oxygen pipes. And that's a standard. You don't get any bigger. No. And your other CPAPs are all electronically controlled high flow, aren't they?
They are, and also sometimes the air starts helping. But also we ran out of, like William explained, we ran out of oxygen.
Yeah.
Many wards are running out of oxygen, so we started staggering our patients, 2 per ward, high flow.
Yes.
Then you'll have to use another cubicle so that there's enough piping to support the flow.
Yes. Yeah, and also, I mean, we've seen during this COVID, the demands for oxygen, I mean, they were battling to keep up to full cylinders.
Yeah.
If you had the big bulk tanks, you're still going to run very short and you're going to run very, very quickly. You're going to run out of them very quickly to have them refilled. So yeah, the high flow is a new sort of thing for us.
I don't think it's the answer because of the design of our hospital and the according to most of our tests, the patient didn't absorb all of that oxygen, even though you gave them a lot.
Correct.
You just used them for the PEEP.
Yeah, but basically it was just to keep the airways open, keep the alveoli and everything
For
out.
driving gas, any driving gas, you don't need to use oxygen for.
No, you can use medical air rather.
Yeah.
I mean, it's cheaper.
It's cheaper. And
Any drive gas, you go through medical air rather.
so this is also where training should be, clinical training should be very important.
Yes.
That they get taught not to go into 60%, 60 liters.
60 litres a minute, yeah. I mean, a patient needing 60 litres a minute.
And it was carbonated.
That's what they're saying about.
Yeah, no, exactly. It should be that would be for a limited period, because the clinician should say, this chap is actually, he's not getting any better on 60. If you're not getting better on 60 litres a minute, you've got to go for intubation. You've got to go your next step, and your next step would be for ventilation.
Unfortunately, this therapy has now taken over a lot of the normal practices, so they are pushing the patient longer on this.
Yes,
just
yes.
to hope for a better, but they're not.
Well,
In my technical opinion.
no, I fully agree, because
We're not clinicians.
no, but a clinician would rather not. I don't know. There's some that just go for intubation straight away, and there are a lot that will no. Let's progressively see how this patient can handle this. So yeah, no, I hear what you're saying. It's us as technicians saying, oh, yeah, you shouldn't use that.
We are sitting with the complaints eventually that there's a whole ward out of ventilators because there's no oxygen anymore. So we have to then deal with it.
Yeah. And there again with this, if you're running out of one, obviously you're going to get your alarms. But say, for example, you have the ideal situation where they both, your air and oxygen are going down. Your ventilators are going to stop, but this thing will carry on, as long as you don't have the big pressure differential, down to sort of, when you're down to 280 kPAs on both of them, and still get 60 litres a minute flow out of it.
Yeah, that's the ideal situation.
But you're never going to get that. Your air is going to be here and your oxygen is going to be there.
It never drops.
No, it will not drop. No.
There's not
Because
enough
you-
points for it to drop.
Yeah, correct. Yeah, you haven't got the big draw out the whole hospital. And there again, you could have these using in one department, then you could have your Venturis in another department. Now, your Venturis, higher flows, lower concentration. Lower flows, higher concentration. So that also brings in another variance to your consumption of oxygen.
No, we're really sitting with a crisis.
No, it is a crisis, yes, absolutely. Even the oxygen, even Afrox, Union Liquid Air, all those guys are saying, we can't cope. We can't cope.
I think we've got an 18-ton cylinder out here and we filled it daily.
Your bulk tank.
Bulk tank.
Yeah,
And
yeah.
it was not keeping
Yeah.
demand. We still
No,
had
it
wards
won't.
who were complaining.
I mean, one ward, how many patients in one ward on something like this at high flows?
Well, you've got 20.
There we go.
And that's in one ward.
That's one ward. 2 years is the big major service. That's like a normal one. You've got sintered filters, you've got shuttle valves, you've got diaphragms, you've got, you name it, all the O-rings, they all should be replaced. Obviously, being with oxygen and air, high flows will create, regulator, high flow, you get water, moisture, so it can create, so yeah. Every 2 years. There is a yearly inspection that's got to be done by us as well. So. These units in the region of about 18,500. Everything on this unit was manufactured in South Africa. The blender, the diaphragms, everything inside that blender was all manufactured locally. Just goes to prove we can do it. Thank you. Thanks very much.